All right, here's your Chapter 11 test review. Number 4, I went ahead and pre-drew the net to save time. It says, draw a net for the polyhedron. Now, all these are on part A until I tell you we're moving to part B. All right, so it says, draw a net for the polyhedron. Well, there's the net for the polyhedron. Now it says, verify Euler's formula, F plus V equals edges plus 1. Remember, since we're working with a net, that's why it's the plus 1 and not the plus 2. All right? So, you count your number of faces. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just remember, faces are the same thing as sides. All right, it's got 10 sides, 10 faces. Now, the next are vertices, so you count all the points. All right? Now, even though there's not technically a point right there where these two edges meet, it's still considered a vertice. All right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. We have 30 vertices. All right, remember you count all these. 1, 2, 3, 4, 5, 6. And you also count all these. 7, 8, 9, 10, 11, 12, 13, 14, 15. And see, we got 15 on that side, which means we're going to have 15 on this side, so that's 30. Equals edges. Basically, edges, you count all the individual lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So we have 39 edges plus 1. 10 plus 30, 40. 39 plus 1, 40. Verified. All right? That's all they wanted you to do for number 4. Draw a net and count everything and verify that the formula works. That's all they wanted you to do. All right, number 5. Number 5 says, what is the number of edges in a prism with pentagonal bases? Well, if you remember, pentagons have 5 sides. That's terrible. Pentagons have 5 sides. All right, so we have one there. So if you think about this, we're going to have a pentagon at the bottom and a pentagon at the top. Now, we're not going to have any vertices connecting them. Okay? I'm sorry, it wants edges. So, 1, so we just connect them all. 2, 3, 4, 5. Now you just count all your individual lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So therefore, E, which is edges, equals 15. All right, a lot of these are easier if you just draw a picture of what they're asking you to do. All right. Now, number 7. All right. For number 7, we have a cylinder being cut by a plane. I know it doesn't look exactly like this, but imagine this as a birthday cake. All right. Imagine this as a birthday cake, and you cut, and you took the knife, and instead of cutting out a slice, you're just like, it's my birthday, I want cake, so I'm just going to take half the cake. All right. So if you cut this, if you took the knife and cut down here, and you took away your section of cake, what would it look like? What would the cake part look like? Not the frosting part, but you know, after you cut that away, that'd just be plain cake. There'd be no frosting on it. What would that actually look like? Well, if you take a cylinder and you cut it in half, you end up with a rectangle. All right, you end up with a rectangle. All right. Hopefully you don't eat half a cake for your birthday. You'll probably end up with a stomach ache or something. That's a lot of cake. That's a lot of sugar. You'll probably be hyper and not get out too. All right. Number 8. Number 8, we have a cone. All right, there's my cone. All right, if we were to take and chop it off right there. All right, we're going to take and chop it off right there. And then we look down at it from the aerial view. Okay, we're in a helicopter. Terrible helicopter. Okay. You got skids. Terrible helicopter. I don't care. Alright, if you were to look down at the top of there, what would it look like? Well, if we were to chop this off, would have a circle in there. Alright, because we're cutting it parallel to the base is a circle, so anywhere you cut this parallel to the base, you're going to get another circle. Alright, you're going to get another circle. All you do is cut the top off the cone, you end up with a circle. Alright, whatever the next one was y'all wanted. It's on the back, so go ahead and flip over page A, I'm going to call it. Number 11. Wants us to find the surface area of a pyramid. Alright, here we go. We have a slant height here of 7. And it says this and 7, and we have our tick marks to show that all 4 sides of the base are congruent. That means that our base is a square. Right? Your surface area formula for a pyramid is base area plus 1/2 perimeter times slant height. Remember the 7 is the slant height here. So since this is a square, our base is simply going to be 7 times 7 because all these are 7. It's a square, length times width, 7 times 7. So our base equals 49. Now, remember this here, you probably can't see that, this is our lateral area. Alright, so LA equals 1/2 PL, which is 1/2 perimeter. Perimeter is simply 7 times 4, which is 28, times slant height, which is 7. Okay? You could cut that down to a 14 if you wanted. So then you just do 7 times 14, or 7 times 28 divided by 2, which comes out to 98. And of course, these are all units squared. What are the units? Centimeters. All these are centimeters squared, by the way. Alright, so now that we have our base and our lateral area, you simply add them together. Because remember, surface area is base plus lateral area. Alright, well there's our lateral area, there's our base. So surface area is simply 49 plus 98, which equals 147 centimeters squared. That is our surface area. Okay, that is our surface area. Alright, let's look at number 12. Number 12, we're doing the same thing but with a cone. Alright, leaving the same formula up there because it basically is the same formula. We just modify the formula a little bit. Alright, surface area. Well, when we have a cone, alright, 10 millimeters, 11 millimeters. Alright, when we have a cone, our base is a circle. So they modify the formula a little bit, but it's essentially the same exact formula. Alright, the formula for the base, which is the formula for a circle, is pi r squared plus 1/2 PL. Well, the perimeter here is going to be the circumference. Circumference is 2 pi r. Alright, now that 1/2 and this 2 will cancel out, leaving the perimeter as pi r, and then you got to multiply in your slant height. Alright, now the diameter is 10, which means the radius is 5, because remember you just divide the diameter in half to get the radius. So this is going to be pi times 5 squared plus pi times 5 times 11. So surface area here is 25 pi plus 55 pi, which equals 80 pi. And they want it rounded to the nearest tenth, so just take 80, multiply it by pi, and you're going to get 251.3 millimeters squared. That's all there is to it. Alright, just remember, this is a diameter, not a radius. If it was a radius, it would have only been this long. But since it goes all the way across, that makes it a diameter. Okay, since it goes all the way across, that makes it a diameter. Alright. Now 13 and 14 work the same way after you get your slant height. So I'm not going to solve these all the way out. I'm going to help you get the slant height, and then it's just simply repeat what you did for 11 and 12. Okay? I'm just going to help you get your slant height. So we know the height here is 15. We know the base is 40. And we want to find our slant height. Well, if you make that a right triangle and pull it out, the height of this right triangle is the height of the pyramid, which is 15. And the base of this triangle is half of the base of the pyramid. So since this is 40, that means this is 20. And of course, our hypotenuse is our lovely friend L. Okay? So you simply use Pythagorean theorem. A squared plus b squared equals c squared. So 15, that's a 12. So 15 squared plus 20 squared equals L squared. 225 plus 400 equals L squared. 625 equals L squared. Take the square root. The square root of 625 is 25. So now, we know our slant height now is 25. So now you can simply take these numbers, plug it into the surface area formula. Alright, well I'm going to work part of it out. So you get the base, which is simply 40 times 40, 1600 plus 1/2 perimeter, which is going to be 160, times your slant height, which is 25. So you could half that down to 80 if you wanted to. But your final answer is going to be 3,600, what's the units? Inches squared. Now I know I skipped a few steps there, but like I said, now that you have your slant height, it works just like number 11, which I did go over fully. Okay? Now let's look at 14. 14 again, after you find your slant height, works exactly like the one above it. Okay, works exactly like number 12. So here our cone's laying over on its side. This is 5, which is a radius. This is 5. We have our height here, which is 12. And we want to find our slant height, which is L. Again, you set up a right triangle. Height of this triangle is the height of the cone, which is 12. The base of this triangle is the radius of the cone, which in this case is 5. And then we have to find L again. So remember, L squared equals A squared plus B squared. So L squared equals 12. I'm going to wipe out a double equal sign. Equals 12 squared plus 5 squared. L squared equals 144 plus 25. So L squared equals 169. Take the square root of both sides. The square root of 169 is 13. Alright, so L is 13, so now you simply plug it back into your formula. Surface area equals pi r squared plus pi r L. So surface area is 25 pi plus 5 times 13, 5. 1, 5, 6, 65 pi. So altogether that equals 100 pi. No, it's 90 pi. Yeah, it's 90 pi, not 100 pi. What am I doing? I'm thinking of a different problem. Sorry about that. I'm thinking of a different problem. This will give you 90 pi. Punch that into your calculator, and you get a total of 282.7 meters squared. All right. I was thinking of a different problem with 100 pi. So that's it for 14. Okay. You should get 282.7. Hopefully I did all my math right, which I'm pretty sure I did. All right. Let's look at number 15 now. It says the net of a polyhedron contains 6 triangles and a hexagon. Well, you have 6 triangles and a hexagon. Well, what does it sound like the base of that figure is? Well, to me, since we have 6 triangles and only 1 hexagon, I would say the hexagon is the base. So 1, 2, 3, 4, 5, 6. Now your 6 triangles. Well, there's 1, there's 2, there's 3, there's 4, and that makes 5 and 6. Okay? So, this is 15. So A, what kind of shape is that? What kind of polyhedron? Well, Since it's a pyramid and it's a regular, and the base is a regular polygon, you can name it by its base. That's a hexagon. So this is a hexagon Al pyramid. Alright, hexagonal pyramid. Letter B. It says if each of these triangles here has an area of 3, and the base here has an area of 6, what is the surface area of the pyramid? Well, the 1/2 perimeter times slant height gives us the lateral area. Well, we know that one of these triangles is 3 and we have 6 of them. So our lateral area is simply the surface area of one of them times however many there are. So that gives us 18. And we know the area of our base, well, they already gave it to us, is 6. So our total surface area is going to be 6 plus 18, because that's the base plus the lateral area, which is going to give us 24, whatever the units were, meters squared. Okay, so B is 24 meters squared. Now C, it wants the volume. Remember, volume is 1/3 base, area of the base times the height. Well, 1/3, we know the area of the base is 6. And now they're saying the height is 2. So that's it. Area of the base we know, and they told us the height is 2. The 1/3 and the 6 will cancel down to a 2, so that is 4 meters cubed. Alright, that's it for that one. They pretty much gave you all the information. All you had to do was plug it into the formulas. Alright? Because they gave you lateral area, because they gave you one triangle, and you know there's 6 of them. So it's 3 times 6 for 18. They told you the base was 6. So you just add the 18 and the 6 to get the 24. And over here, again, we know the area of the base is 6. Our formula is 1/3 area of the base times height. 1/3 times 6, they tell you the height's 2. Alright? That's just a matter of doing the math right there. Alright, and the last one is 16. 16 says, suppose you build a polyhedron from 2 octagons and 8 rectangles. Without using Euler's formula, how many edges does the solid have? Alright? Without using Euler's formula. Well, the easiest way to do this, so you don't make a mistake, is just draw it out. Just draw it out. But also, if you turn over to the front side of this test, number 4, isn't that the same thing that they're describing in number 16? A polyhedron from 2 octagons and 8 rectangles? Looks like it to me. How many edges were there? 39. And again, you can just, if you're not sure, or say it said hexagons. Well, we didn't do one with a hexagon, I don't think. No, we didn't. So, easiest way to do it, draw your figure and then just count them. Easiest way to do it. Draw your figure and just count them. Okay? Alright, part B. Head over to part B now. Number 4. It says, find the volume. Alright, now we're on part B. Number 4, we have a cone. If you notice, this cone is the same cone from the other one that we found surface area for. Now we're just finding volume. Well, remember, volume, 1/3 area of the base, which in this case is pi r squared, times the height. So the volume is 1/3. R squared is 25 pi times our height, which is 12. The 12 and the 3 are reduced down to that, make a 4. So this comes up to 100 pi. I believe they want it to the nearest tenth. Yes, they do. So that's simply 314.2 units. What were they? Meters squared. Okay? That's all there was to that. Now, if you don't remember that pi, it rounds to 3.142 when you round it to the hundredths place, you can just punch that into your calculator and go from there. Alright, that's all there is to that one. That one's just simple plug into the formula problem. Alright? Didn't have to find anything but the volume. We had everything we needed to find the volume. Number 5. Now, the way they worded number 5 was a tad tricky, but the key word that they left out here was they're similar. Okay, we know that we have two cans. We have a small can. Oops. We have a bigger can. Okay. We know that the volume of the regular can is 60. And we know that the area of both bases is 10. Okay? Well, isn't volume simply area of the base times height? Well, we have the area of the base. The area of the base is 10 for the small one, and we have the volume for the small one. So, volume equals 60. Okay? Our base is 10, but we don't know the height. Well, divide both sides by 10, and look there. We now know the height of the smaller can is 6. Alright, because all we did was plug it in. We just plugged in the numbers they gave us. We had everything but h for the volume formula. They gave us everything but h for the volume formula. So all we had to do was find it. So we know that this is 6. Well, now we know that the taller can is 3 inches taller. Inches, right? Centimeters. We know that the taller can is 3 centimeters taller than this, so 6 plus 3 is 9. And now they want us to find the volume of the larger can. Well, volume is base area times height, so volume equals 10 times 9. Volume equals 90 centimeters cubed. Okay, centimeters, 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 centimeters. Alright, so that's all there was to that one. It seemed like a little bit of a difficult problem on when you first read through it. But when you draw pictures and you start to fill in what you know for your volume formula, it really simplifies it down pretty well. Alright, it really simplifies it down pretty well. Alright, now the next two that were requested were 7 and 9. They work the same exact way. The only difference is for 7 they give you a radius, for 9 they give you a diameter. So I'm going to work 7 and then I'm going to basically tell you the diameter for 9, and then you just work it exactly like you did number 7. I don't know what that was supposed to be. Alright, we have a sphere with our center point. Alright, we know our radius is 11 inches. And we want the surface area and the volume in terms of pi. Alright, let's start with surface area. We know that is 4 pi r squared. Alright, so surface area equals 4 pi 11 squared. So that's 4 pi times 121, because that's what 11 squared is. So surface area equals 121 times 4, which is 484 pi inches squared. Again, they gave you the radius. That's just a straight plug into the formula problem. Alright, now volume. Remember, volume equals 4/3 pi r cubed. Well, again, we have r, so you just simply start plugging in. Alright, volume equals 4/3 pi. 11 cubed is 1331. So now you simply plug this in. So you multiply this by this, and you're going to get 1774 2/3 pi. Alright, just take 4/3, multiply it by 1331. Remember, you could always just do 1331 times 4, hit enter, get that number, divide it by 3, and you should come up with 1774 2/3 pi inches cubed. Because remember, we're on volume now. This is the volume, that was the surface area. Okay? Now, if you look at number 9, see what I did there? Alright, if you look at number 9, the only difference is this. Now they do this, and they put an error here, and they say 5 centimeters. Okay? Well, that's a diameter. The diameter is 5 centimeters. Okay? So, what we want to find is we want to find the radius. Well, the radius is simply half of 5, which is 2.5. Alright, so now instead of using 11 here, you're going to use the 2.5. And the same thing here. Instead of using 11, you're going to use the 2.5. But you're still going to do the problem the same way. You just plug it into your formula. Alright, for number 9, the surface area Well, I didn't write it down, but the answer key is on the website. Okay? So you just plug in the new radius, which is 2.5, to the here and to there, and you work the problem the same exact way. Alright? Number 10. Number 10, it says the circumference of a standard bowling ball. Well, there we go. We know circumference. Let's start writing stuff down. Circumference is 2 pi r. Okay, we know that. Then it says the circumference of a standard bowling ball is about 27 inches. To the nearest unit, so we're rounding to a whole number, how many square inches is the surface area of 100 bowling balls? Okay, well, we know surface area is 4 pi r squared, and since we want 100 bowling balls, we're going to take that number and multiply it by 100. So, that formula, 4 pi r squared times 100, will give us the surface area of 100 bowling balls. Now, you can simplify this to 400 pi r squared. All I did was multiply the 100 by the 4. 400 pi r squared. Now, let's leave that alone for a second, because now we have to find r. Because without r, none of this is going to be possible. So, since we know the circumference is 2 pi r, and we know the circumference equals 27, we know 27 equals 2 pi r. Divide by 2 pi. Alright, now remember, if you punch this in the calculator, and you don't use the N over D button, if you just string this out, like this, make sure you put the 2 pi in parentheses. If you don't put the 2 pi in parentheses, it's going to go 27 divided by 2 and get 13.5, and then it's going to say your answer is 13.5 times pi, which is not the answer. What it's going to do is, this way, it'll multiply the 2 times pi and get 6.28, and then do 27 divided by 6.28, which will give you 4.297 for a radius. Now, leave this answer with the entire decimal in your calculator ready to go. Don't clear it. Don't do anything. Leave it there with the whole decimal, because we don't want to round yet. Okay? Now, since we know we're going to square r, go ahead and hit that x squared key, and on the calculator it's going to say answer squared. Hit enter. You should get like 16 or 7. You should get 16 something, maybe 1700, depending on what the decimal does, but I think it's 1600. All right. Now that we have r squared, okay, times that now. Okay, hit enter. That'll give you a number. Now do answer times 400 pi and hit enter. Okay? If it gives you a number and with pi, just hit the up arrow. Okay, the up arrow is that button like this, and it has the little like that on it. Hit the up arrow to highlight that number. Hit enter. It'll pull that number down here. Hit the button above enter, and it'll put little greater than less than signs, and hit enter again, and it'll change it to a decimal. Okay? Once it changes it to the decimal, your surface area is going to come out to 23,205 inches squared will be your surface area. Alright? But remember here, this is the most important part. After you find your radius, okay, don't just type back in 4.297 squared. Okay? After you do this, immediately hit that squared key. It's the x to the squared button. It'll come up answer squared, which means it's going to pull that whole decimal in. Alright? After you do that and you have that whole decimal, hit times 400 pi. Hit enter, and I believe it should go ahead and come out to 23,205, but if it doesn't, just hit the up arrow to highlight the answer that it just gave you. It'll pull that answer down here. Then hit the button right above enter. It'll put the 2 little arrows, hit enter again, and then for sure it will give you a decimal. Alright? Alright, 5 more to go. Turn the page over. Let's look at number 11. Look at number 11. What's the volume of the figures to the nearest tenth? All right, here we have a cylinder. Radius of 5, height of 4, units are meters. So, volume of a cylinder, pi r squared height. So, just go ahead and fill in your numbers. Volume equals pi r squared height. So, volume equals 5 times 5 is 25. 25 times 4 is 100 pi. And it wants to the nearest tenth, so volume is going to be 314.2 meters cubed because we're doing volume. Okay, so it would be 300.2 meters cubed. Again, that's just a straight plug into the formula problem. Okay, straight plug into the formula problem. Alright, number 13 now. We have 2 cubes. I'm going to leave out the dashed lines to make it look a little cleaner. 9, 9, 9. Then we have another one over here, which is 12, 12, 12. He wants to know, are they similar? Well, 9, 9, 9, 12, 12, 12. All the dimensions are the same for each one, which means if you compare the lengths, you're going to get 9 over 12. If you compare the widths, you're again going to get 9 over 12. If you compare the heights, you're again going to get 9 over 12. Since all of these fractions are identical, yes, they are similar. Now, to get the similarity ratio, they call it scale factor. Okay, to get the scale factor, which is also the perimeter ratio, PR. Okay, you just simply reduce this. Well, if you pull a 3 out of here, you get 3. If you pull a 3 out of here, you get 4. So there's your answer for 13. But yes, they're similar. Your scale factor, which is your similarity ratio, which is also your perimeter ratio, same thing, 3 different names, is 3 over 4. All right? Now, let's go to 14. I'm going to use the same 2 figures for 14. All right, here we have 4 is a height, 2 here, 3 here. Yes, I'm moving the numbers around a little bit. 9, 6, and 6. I'm moving the numbers around a little bit because they're easier to look at this way. All right, so we need to find out, are they similar? Well, let's compare the lengths. That's 3 over 9. Let's compare the widths. Well, that's 2 over 6. Compare the heights. Well, that's 4 over 6. Okay, do all of these equal each other? No. These 2 equal 1/3 because you can pull a 3 out of the top, 3 out of the bottom. Pull a 2 out of the top, 2 out of the bottom. But here, if you pull a 2 out of the top and a 2 out of the bottom, you get 1/3 equals 1/3 equals 2/3. Well, this one doesn't work. Since one of them doesn't work, they are not similar because all 3 dimensions do not have the same scale factor, similarity ratio, or perimeter ratio, whatever you want to call it. Okay? So that is number 14. They are not similar. Not similar at all. Okay? Number 15. It says the volumes of 2 similar prisms. Well, since we're talking about volumes, we know immediately that we're probably gonna have to get a volume ratio. All right, the volumes of 2 similar prisms are 972 and 36. 972 over 36. Remember, if you use that N over D button on the calculator, you can actually type 972 over 36 into it, hit enter, it'll automatically reduce it for you. But make sure you're in math print mode or it won't work. Alright, if you do that, it's going to reduce this down to 27 over 1. So our volume ratio is 27 over 1. Now, then it starts to talk about surface area. But remember, before we can go to the area ratio, we have to make a stop by the perimeter ratio first. Alright, and remember, to go from volume ratio to perimeter ratio, you cube root your volume ratio. All right, so the cubed root of 27 is 3. Cubed root of 1 is 1. Now we've got to go up to the area ratio. Remember, you take your ratio and square it to get up to the area ratio. 3 squared is 9. 1 squared is 1. So our area ratio is 9 over 1. All right, now let's look at the problems. We have two problems, A and a B. A wants to know what is the scale factor. Remember, scale factor, perimeter ratio is the same thing. So the scale factor is 3 over 1, 3 to 1. Okay? Now we want the surface area of the smaller one. So, since we're dealing with surface area, we're dealing with area, we're using the area ratio. So 9 over 1, that's our area ratio. Remember, this is big over small. So, when we do our proportion, we want big over small. And it says the surface area of the larger prism is 594, and we're looking for the small, and we don't know what it is. So, this is what your proportion should look like. If you wrote 1 over 9 equals x over 594, you're okay too. Here, if you wrote this as 1 over 3, you're still okay because they didn't say the ratio of the larger one to the smaller one or the smaller one to the larger one. So you can technically write it any way you want because they didn't specify. Okay? So now that we have our proportion here, you simply cross multiply. 9x equals 594. Divide both sides by 9. So x, which is the surface area of the smaller one, is 66 centimeters squared. Okay? 66 centimeters squared. That's it for that one. Remember, volume ratio to perimeter ratio, you cube root your volume ratio. Then to go from perimeter up to area, you take it and you square it. When you square a fraction, you square the top and the bottom individually. Okay? You square the top and the bottom individually. Do not try to square them and then add them together somehow. Okay? Square the top, 9. Square the bottom, 1. 9 over 1. Leave it alone. Alright, number 18. This is the last one. Yay! Y'all are probably excited too, especially if you've watched this whole thing by now. Alright, 18. Error analysis. So, you read along as I read along. It says, 2 cones have the same volume but different heights. The taller cone is 9 times taller than the shorter cone. Your friend concludes that the radius of the shorter cone must be 9 times longer than the radius of the taller cone. What is his error? Alright, let's draw 2 cones, just for a visual. Alright, the smaller cone. We know this one is 9 times larger. Let's call the height here x, the height here 9x. So now we need to look at the radius. Okay, we'll call this y. He's saying that this has to be 9y. Okay? Your friend, he or she, I don't know. I don't think it specifies. Alright? He says it's got to be 9 times. But here's the error. In the problem, it never says that these 2 cones are similar. It never says that. So therefore, we don't have to worry about a similarity ratio. Alright? Because if these were similar, he would have been right. It would have had to have been 9 times bigger. But if you think about it, if it is, they wouldn't be similar at the same time. So, they are not similar cones. So we don't have to worry about, because the heights here would be a 9 to 1 ratio. But since they're not similar, we don't have to keep that 9 to 1 ratio for the radius of each cone. Okay, we don't have to keep that. So, what the error is made is your friend did not consider that base equals pi r squared. Okay, it's radius squared. So, in order for these to have the same volume, but this has a 9 times greater height, your radius only has to be 3 times larger on the smaller cone. Because when you square it, you get the 9. Okay? That's why you get the 9 times larger dealing with the radius is after you square the number. Not the radius itself, but the radius squared gives you the 9 times larger. Okay? I'm sure you're like, yeah, whatever, prove it. All right, let's prove it. Okay? Let's say this had a height of 18 and a radius of 2. If this one's 9 times larger than this one, this has to have a height of 2, right? Because 9 times 2 is 18. It has to have a height of 2. Okay? For the larger one to be 9 times taller. Now, sticking with the correction that it has to only be 3 times larger, the radius here is going to be 6, because 2 times 3 is 6. Now, if we do our volume formula here, we know that the volume is going to equal 1/3 pi r squared height. So volume equals 1/3 pi r, which is 2, squared height, which is 18. That goes with that. What does that make? That is 6. 6 times 3 is 18. Yep. So volume equals 4 times 6, which is 24 pi. Okay, so there we get 24 pi. Let's do it over here. 1/3 pi r squared height. Volume equals 1/3 pi 6 squared times 2. Volume equals 1/3, I don't know why I'm writing crooked. Probably because it's easier to do over here. Let me write that over again. Volume equals 1/3 pi r squared height. Volume equals 1/3 pi radius squared times 2. So volume equals 1/3 pi times 36 times 2. Well, the 1/3 and the 36, that goes to a 12. So volume equals 2 times 12, which is 24 pi. Looky there. It works. Okay? So, the reason the friend made the error is because he automatically assumed that since the height of this one was 9 times larger, the radius of this one would have to be 9 times larger. But since the radius is squared, that means that this radius only has to be 3 times larger to make up for the difference in height. Alright? So, here's basically a visual proof of why the friend made a mistake. And if you did this with the 9, that means this would have to be 18. Okay? And if you did it with 18, it would definitely not work. Volume equals 1/3 pi r squared times 2. 1/3 pi 2. What's 18 squared? I didn't calculate that. 8 times 8 is 64. 8. And that's 14. 0, 8, 1, 4, 12, 1, 3. 324. Hope I did that right. I did it quick. So as you can see here, when you times this by 2, this is going to be 648. Divide that by 3, you are not going to get 24. Alright? So, remember, again, since you're squaring the radius only has to be 3 times larger to make up the difference. Alright? So, there's your test review. Watch as many times as you need to. Make sure you come Monday ready to take the test. See you tomorrow.